NEIL. Imagine falling into a black hole. In your final moments before spaghettification, you'd witness the entire future of the universe flash before your eyes. The end of time itself, compressed into seconds. And NASA doesn't put that in their brochures. NEIL. The universe is under no obligation to make sense to you. But I am. I'm Neil deGrasse Tyson, and in the next 45 minutes, I'm going to reveal cosmic truths that will fundamentally transform how you perceive your place in the universe. We'll explore 5 shocking revelations about space that rarely make it into NASA press releases or textbooks, not because of some grand conspiracy, but because some cosmic truths are simply too profound, too unsettling for casual conversation. You'll learn why time is not what you think it is, how your very atoms connect you to the cosmos in ways you never imagined, and why the search for alien life might be looking in entirely the wrong direction. Stay with me, and I promise your cosmic perspective will never be the same. NEIL. Let me ask you something that might sound simple but isn't. What time is it in the universe? That's not a trick question. It's actually impossible to answer. And this is our first revelation that doesn't make NASA headlines but fundamentally changes everything. You see, when we look up at the night sky, we're not seeing the universe as it is. We're seeing it as it was. That star points the light from it might have taken 100 years to reach us. That galaxy points further 2.5 million years. We are cosmic archaeologists every time we look up. When I was about 9 years old, I visited the Hayden Planetarium for the first time. The presenter dimmed the lights, and suddenly the ceiling transformed into the night sky. I was transfixed. But what nobody told me then, what took years of astrophysics study to fully grasp, was that I wasn't just looking at different places in space, but different moments in time. Here's what NASA doesn't typically emphasize in their beautiful space images. There is no universal now. Einstein showed us that time is relative, but the implications are far more profound than most people realize. When astronomers say they've discovered a galaxy 13.4 billion light-years away, they're not just saying it's far. They're saying we're seeing it as it existed 13.4 billion years ago, when the universe was young. But here's where it gets truly mind-bending. Imagine aliens living in that distant galaxy with powerful enough telescopes to see Earth. What would they observe? Not us having this conversation. They would see Earth as it was 13.4 billion years ago. A young planet with no life forms more complex than single-celled organisms. We exist in their future, while they exist in our past. And yet in the cosmic present, if such a thing could be said to exist, we're both here now. This isn't just a quirk of astronomy. It's a fundamental property of our universe that reshapes how we should think about our place in it. But wait, I've opened 2 questions I haven't answered yet. First, if there's no universal now, how does NASA synchronize space missions across the solar system? And second, could this time dilation effect ever be harnessed for practical purposes, perhaps even as a form of cosmic time travel? We'll get to those. But first, let me show you something even more profound about your connection to the cosmos. NEIL. Holding up a small vial with glittering particles, what I'm holding appears to be glitter, but imagine it's the carbon in your body. Every atom of carbon in your body, the backbone of your DNA, your proteins, much of your cellular structure, was forged in the heart of a dying star billions of years ago. When Carl Sagan said we are made of star stuff, it wasn't poetic license. It was literal astrophysical fact. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, none of these elements existed in the early universe. They were created through nuclear fusion in stars, and then scattered across space when those stars died in spectacular supernovae. NASA has documented the spectral signatures of elements in countless stars and nebulae. What they don't typically emphasize in their press releases is the profound implication. You are, quite literally, recycled stars. Let me share something personal. When my father passed away, I found profound comfort not in traditional notions of an afterlife, but in this cosmic perspective. The atoms that composed his body, that made him who he was physically, didn't disappear. They returned to the earth to be recycled into new forms of life. The same cosmic recycling that brought those atoms from ancient stars to form him will continue long after all of us are gone. But here's what's truly mind-blowing. The heavier elements in your body could only have been created in the spectacular deaths of stars. So not only are you made of star stuff, you're made of the remains of stellar catastrophes. Your existence required cosmic destruction on an unimaginable scale. NASA has captured stunning images of supernova remnants, but they rarely frame it this way. These beautiful cosmic explosions are the factories that made your existence possible. We are all, in a very real sense, children of the stars. Think about this the next time you sit down for a meal. That apple, star stuff. The water in your glass, hydrogen formed in the Big Bang, oxygen from stellar fusion. Your dining companion, an intricate arrangement of atoms forged in cosmic furnaces. This leads me to two questions we haven't addressed yet. If we're made of the same elements as stars, why don't we shine like they do? And if all matter in our solar system came from previous stars, does that mean our sun is actually a second or third generation star? We'll get to those. But first, let's talk about something even NASA struggles to explain to the public: the true nature of space itself. NEIL, demonstrating with a vacuum chamber. When NASA sends spacecraft through the vacuum of space, they're navigating through something far stranger than emptiness. The popular conception of space as a void couldn't be further from the truth. Even in the emptiest regions of space, quantum physics tells us that the vacuum is actually a seething sea of virtual particles popping in and out of existence. Particle-antiparticle pairs spontaneously appear, annihilate each other, and disappear, all in timeframes so short we can barely measure them. This isn't just theoretical. The Casimir effect demonstrates that these virtual particles create measurable forces. And black holes actually evaporate over time because of this quantum activity at their event horizons, a phenomenon called Hawking radiation. Mid-roll engagement prompt: I'm curious, does this change how you think about empty space? Comment below with what you find most surprising about the quantum vacuum. Are you team space is empty, or team space is full of quantum activity? Hit like if your mind is already expanding faster than the universe. When I was in graduate school, one of my professors demonstrated this concept with a simple analogy. He inflated a balloon and drew galaxies on it with a marker. As he inflated it further, the galaxies moved apart. Where, he asked, is the center of the expansion? The answer surprised everyone. There is no center on the surface of the balloon. Every point sees all other points moving away. The same is true of our universe. there is no center of the expansion of space. From every galaxy's perspective, all other galaxies appear to be moving away. We're not expanding into anything. Space itself is expanding. This leads to something NASA rarely emphasizes. Most of the universe is fundamentally unreachable by humans. Due to the accelerating expansion of space, galaxies beyond a certain distance are receding faster than the speed of light. Their light will never reach us, and we can never reach them, not because of technological limitations, but because of the fundamental nature of space itself. But this raises two questions. If space is expanding, what is it expanding into? And if virtual particles are constantly appearing and disappearing in the vacuum, could we ever harness this energy, perhaps as a revolutionary spacecraft propulsion system? We'll address those soon. But first, let's talk about something that might be even more shocking. What NASA's search for extraterrestrial life might be missing entirely. NEIL. Standing next to SETI radio telescope imagery for decades, NASA and organizations like SETI have scanned the cosmos for radio signals from alien civilizations. The assumption has always been that intelligent life would communicate using technology similar to ours. But this approach might be fundamentally flawed in ways that rarely make it into public discussions. Think about it. We've only been transmitting radio signals for about 100 years, a cosmic eye blink. Any civilization even slightly more advanced than ours might have moved beyond radio to communication methods we can't even conceive of yet. It would be like ancient Romans looking for smoke signals from alien civilizations, while completely missing fiber optic communications. But there's an even more profound issue with our search paradigm. We're looking for life that's fundamentally similar to Earth life, carbon-based, water-dependent oxygen breathing. Yet even on our own planet, we've discovered extremophiles that thrive in environments we once thought were uninhabitable. In 2019, I visited a laboratory where scientists were studying organisms found near hydrothermal vents in the deep ocean. These creatures live in pressures that would crush a human and temperatures that would boil our blood. They derive energy from chemical processes completely independent of sunlight. If life can take such diverse forms just on Earth, imagine the possibilities elsewhere in the cosmos. Silicon can form complex molecular chains similar to carbon. Ammonia could potentially serve as a liquid medium for biochemistry instead of water. Methane, sulfuric acid, even liquid nitrogen, all could theoretically support some form of life. NASA has discovered thousands of exoplanets, but their public emphasis has always been on finding Earth-like worlds. The shocking truth is that we might be overlooking entire categories of habitable planets simply because they don't fit our narrow Earth-centric definition of habitability. And then there's the time factor. Human civilization has existed for a mere few thousand years. The universe is 13.8 billion years old. Intelligent civilizations could have risen and fallen millions of times over before Earth even formed. The chances that we're overlapping with another technological civilization at precisely the same evolutionary stage seems increasingly unlikely. This leads to two profound questions. If alien life is fundamentally different from what we expect, would we even recognize it if we found it? And given the age of the universe, should we be looking not for living civilizations, but for the artifacts of long-extinct ones? But before we explore those questions, let's confront perhaps the most unsettling revelation of all. one that NASA scientists understand but rarely express in public forums. NEIL, standing beside a scale model of the solar system, when NASA releases those stunning images from the James Webb Space Telescope showing thousands of galaxies in a patch of sky the size of a grain of sand held at arm's length, they're revealing something profound about our cosmic significance, or apparent lack thereof. The numbers are literally astronomical. There are roughly 100 billion stars in our galaxy, and approximately 2 trillion galaxies in the observable universe. If you wrote out the number of stars in the universe, it would be a 1 followed by 24 zeros. And that's just what we can observe. The actual universe is likely vastly larger, perhaps infinite. In cosmic terms, we are smaller than small. Earth is a pale blue dot, as Carl Sagan eloquently put it. A mote of dust suspended in a sunbeam. Our entire civilization, all our wars, all our triumphs, all our art and science and love and hatred, has played out on this tiny stage in an incomprehensibly vast cosmic arena. I remember the exact moment this perspective truly hit me. I was a graduate student working late in the observatory. I'd been analyzing spectral data from distant galaxies for hours. When I finally stepped outside, I looked up at the night sky and was struck by a wave of vertigo. Not from the physical act of looking up, but from the sudden, visceral understanding of my cosmic insignificance. But here's the revelation that NASA doesn't emphasize enough. Our cosmic insignificance paradoxically makes us extraordinarily significant. As far as we know, we are the only species in the entire universe capable of understanding the cosmos. We are the universe's way of knowing itself. Think about that. Hydrogen atoms, forged in the Big Bang, spent billions of years coming together to form stars, planets, and eventually, on at least one world, life forms complex enough to contemplate their own origins. You are the universe becoming conscious of itself. This leads to what I call the cosmic perspective. Yes, we are small. Yes, on the scale of the universe, our lives are brief flashes. But we are connected to everything. The same physical laws that govern distant quasars govern the synapses firing in your brain as you process these words. And this perspective changes everything. Borders between nations look arbitrary from space. Our differences seem small. Our common humanity, our common cosmic heritage becomes evident. This raises two profound questions. If we are the universe becoming conscious of itself, do we have a cosmic responsibility to preserve and expand that consciousness? And if we truly internalize this cosmic perspective, how would it transform our societies, our priorities, and our treatment of this pale blue dot we call home? We'll address those. But first, let's explore what may be the most practical revelation: how understanding cosmic threats might be essential for our survival. NEIL, standing next to asteroid impact simulation display NASA tracks near-Earth objects, asteroids and comets that could potentially impact our planet. The public generally knows this. What's less discussed is the true scale of cosmic threats and how utterly unprepared we are for most of them. An asteroid just half a mile wide striking Earth would release energy equivalent to 100,000 megatons of TNT, more than all nuclear weapons ever tested combined. It would trigger earthquakes, tsunamis, and firestorms, and send enough dust into the atmosphere to cause global crop failures. And that's just a moderate-sized impactor. While NASA has made progress identifying larger objects, we're still largely blind to many smaller ones that could cause regional catastrophes. And asteroids aren't even the most concerning threat. In 1859, a massive solar storm called the Carrington event hit Earth, causing telegraph systems to fail and auroras visible as far south as Cuba. If a similar event happened today, it could disable satellites, knock out power grids, and cause trillions in damages. Our increasing dependence on technology has made us more vulnerable, not less, to these cosmic events. But there are even larger-scale threats. Gamma-ray bursts, enormous explosions that occur when massive stars collapse, can sterilize entire regions of a galaxy. If one happened within a few thousand light-years of Earth, it could deplete our ozone layer and trigger mass extinctions. These aren't science fiction scenarios. They're well-understood astrophysical phenomena. The question isn't if Earth will face another major cosmic impact or solar event, but when. And our civilization's ability to anticipate and respond to these threats will determine our long-term survival. This brings me to what may be the most important revelation of all. Becoming a multiplanetary species isn't just an adventure, it may be an evolutionary imperative. Earth has experienced at least 5 major extinction events. The dinosaurs didn't have a space program, and look what happened to them. NASA's missions to the Moon, Mars, and beyond aren't just about exploration or national prestige. They represent the first tentative steps toward creating a cosmic insurance policy for humanity. By spreading beyond Earth, we reduce the chance that a single catastrophe could end human civilization. This perspective changes how we should think about space exploration. It's not a luxury or a distraction from Earth's problems. It's a necessary investment in humanity's long-term future. So where does this leave us? With a choice. We can remain a single-planet species, vulnerable to cosmic threats beyond our control. Or we can embrace our role as cosmic pioneers, spreading consciousness and understanding throughout our solar system and perhaps, someday, beyond. NEIL. Standing against Starfield background, we've covered some profound territory together. From the illusion of universal time to the quantum nature of vacuum. From our stellar origins to our cosmic significance. From our search for alien life to the existential threats that may shape our future. These revelations don't make headlines because they're not events, they're perspectives. Ways of understanding our place in the cosmos that transform how we see everything else. My hope is that you'll carry this cosmic perspective with you. That the next time you look up at the night sky, you'll see not just stars and planets, but your extended cosmic family. That you'll recognize yourself not as separate from the universe, but as an intrinsic part of it, the universe experiencing itself. If you found this cosmic journey valuable, I have more to share with you. On my channel, you'll find deeper explorations of black holes in the event horizon's edge, and a mind-bending look at quantum reality in the universe's quantum shadows. Click the links on screen now or in the description. And remember, the universe is under no obligation to make sense to you. But with curiosity, science, and perhaps a bit of cosmic humility, we can make sense of our place within it. Until next time, keep looking up.